the first two are pretty straightforward because these are the types where there's no horizontal asymptote rule. It's more of just basing your answer on the parent graph, because e to the x, we should know, is just an exponential function. And as we are approaching negative infinity, raise your hand if you can tell me what your y is getting closer to. Lexi? 0. Good. So that is 0. Nick, do you have a question?
No, just...
Okay. Jump to B. Similarly, not a parent graph, but it's a parent graph that's been transformed. Raise your hand if you can tell me how it's been transformed. Joseph?
Reflection over the x-axis?
Over the y-axis, because it's horizontal. Because the negative is in the exponent and it's within the function, it's a horizontal movement. So that's the same exponential graph, just flipped horizontally. So as x approaches infinity, our limit here is 0 as well. Hannah.
So if it were to be flipped over
The x-axis, that would look...
There would be a negative?
Oops.
Okay.
Yep, the negative would instead be out in front.
Okay.
And then that would flip. That would definitely, obviously, mess with some of the end behavior. Still approaching 0 this way, but approaching negative infinity that way as opposed to positive infinity on the parent graph. Kristen.
If it was what you just accidentally wrote, like negative e to the negative x, would the negative e cancel, or like?
Oh, no. So negative e to the negative x flips twice.
Oh.
So it's going to flip horizontally first to here, and then it's going to flip vertically, so it would be like that.
Oh, okay.
Okay, so the parent graph, kind of manipulating some transformations, and it's great when we can do that, but again, that doesn't happen that often. And there are so many types of functions out there that are not cut and dry in a certain category, like this one. So if we consider this function, which is a combo of a rational and an exponential, I first thought, think about f of 100, and that would kind of mimic f of infinity, or at least get you in the numerical ballpark. And f of negative 100 would mimic negative infinity. Obviously, you can get much larger and much smaller. Because I thought concrete examples might be the better way, but I think we've plugged in infinity enough and negative infinity enough already to be able to wrap our heads around that. So I'm just going to do f of infinity, sort of. So I'm going to be looking for the limit as x approaches infinity on 1 over 1 plus e to the negative x. So when I plug in infinity, 1 over 1 plus e to the negative, because the negative is a part of the function, infinity, we first need to look here. And what's happening to that value as we go towards infinity? Hannah? Okay, she's correct. I'm going to show you why that is, because it's 1 over 1 plus the negative exponent goes to a denominator. So this becomes 1 over e to the infinity. And 1 over a humongous number is like 0. So this is 1 over 1 plus essentially 0, and 1 over 1 plus 0 is just 1. So there is a horizontal asymptote at 1. No rule that you know, no parent graph that you know would ever tell you that. But you can plug in infinity and think it through and figure out that as you go towards infinity, this is approaching 1. And that's what horizontal asymptotes do, is they guide that end behavior. Does that make sense? Mackenzie.
I thought if there was a negative exponent in the denominator, you could just move it.
If the negative exponent is part of a monomial, so like if it's x to the third over y to the fifth z to the negative second, that's a part of a monomial, so that does just come up. But this one was a part of a binomial. All right, so same thing, we're going to do the limit as x approaches negative infinity. Any guesses before you plug it in as to what that might be? Ryan?
Would the negatives cancel themselves out? So when you plug it in,
Yes.
So A would just end up.
Yeah, but before you plug it in, any gut feeling as to what the answer would be, Kristen?
Well, I kind of like thought about it, but my guess is 0.
Okay. Anybody else have a different guess before doing it? Don't give me your guess if you've already thought it through. Okay. So when I plug this in, 1 over 1 plus e, here's what Ryan was talking about. The negative that's a part of the function and the negative infinity that you plug in, yes, that double negative will become positive infinity. So 1 plus e to the infinity, which is a humongous number. And a humongous number plus 1 is still just a plain old humongous number. So this is just 1 over huge, which is 0. Nice job, Kristen. So now what this tells us, because we found the limit going towards negative infinity, is that as we go towards negative infinity, there is another horizontal asymptote at 0. So this particular one has 2 horizontal asymptotes that, again, no rule that we've ever learned is going to tell you. But if I do this window from, I'll do negative 50 to 50 and negative 5 to 5. Oh boy. Okay, so you don't see a lot of the beginning part of it because it's already going along the x-axis when you go towards negative infinity. But if I zoom in and just do like negative 2 to 2, and I don't quite do negative 50, maybe I'll do negative 20 to 20, you'll see a little bit more of it come up here. Does some strange, unpredictable behavior in the middle, but then again, your horizontal asymptote moving towards infinity becomes clear. Any questions on this so far? Okay, flip over. This first example, just a basic trig function, sine x. We've looked at the graph. We know that the graph constantly is oscillating between negative 1 and 1. So as we go towards infinity, this graph isn't kind of narrowing down on a horizontal asymptote. So this one does not exist. Tori? But that doesn't mean that just because we have a sine x in the problem that it's not going to exist. So here's another function that contains a sine of x, but the answer is not going to be does not exist. Think about plugging infinity into this one. Give me 1 second. And I want you to think about the numerator first. The numerator's limit doesn't exist. It's going to keep going back between 1 and negative 1, right? So at max, that numerator is going to be positive 1 over a huge number. And at minimum, the numerator is going to be negative 1, because the sign of anything has to be between negative 1 and 1. So negative 1 over a huge number. So it's going to keep oscillating back and forth between a positive and a negative. But as the denominator gets bigger and bigger and bigger, both of these are going towards, raise your hand, Joseph, 0. So this, even though the numerator itself oscillates, the denominator is so gigantic that whether it's 1 or negative 1, it doesn't really matter. It's getting closer and closer to 0. Now, on a side note, before I get to your questions, this is a graph that we have looked at before. This is our limit graph that when we got an undefined, when we were looking for the limit as x approaches 0, this graph goes like this, if you remember. So it does oscillate above and below the x-axis, positive to negative, but it eventually just kind of, at least to the naked eye, it appears like it flatlines along the x-axis. And that's your limit of 0 coming into play. So now, there were several hands, so who still has a question? Ryan.
Why wouldn't that rule of sin x over x equals 1 apply?
Okay, that is only, does someone answer that? Kristen.
Because it's when x approaches 0.
Right, that rule is for the indeterminate case. When you plug in 0 and you get 0 over 0, we learned that actually that limit rule is only on that graph only is when you're approaching 0. And this is approaching infinity. Okay, any other questions? Tori?
Like, what if you remember that graph from when we learned that rule?
That's fine. Yep. But I'm also, in some, both can work. The idea of plugging in infinity might be easier for some people, and because they don't know the graph, or they just like to plug in infinity to wrap their head around it anyway. Or the picture, certainly in some, both are possible. Some, only one of those methods is possible. So you kind of got to do whatever method works for you. Tori?
Why does the graph level out? Why does it keep going the curve?
Why does it level out at 0?
Yeah.
Because the numerator is always a small number. And the denominator is continuously getting bigger and bigger. So 1 over 100 versus later on you're going to get 1 over 1,000,000.
Oh, okay.
Anything else? Okay. This one is entirely new to us. We've never seen this graph, so you can't go the graph method. You have to think about plugging in infinity. So take a minute on your own to think that through. And if you are finished, also look for the limit as x approaches negative infinity on the same function. And see what you think. I will tell you the answer is does not exist. So don't put does not exist, because there should be a numerical answer for both of them. All right, Lauren, what did you get for the first one? Raise your hand if you got 1. Nice. So if you plug in infinity, oops, it's cosine of infinity. The main thing we have to think about is the cosine of infinity, because that portion of this is oscillating anywhere between a 1 and a -1. So I like to kind of think about it, at most this would be -1 over infinity, and at most, or at least on the denominator, the smallest that this could be would be -1 over infinity. So essentially you're looking at infinity -1 versus infinity +1 in your two different scenarios. When you're dealing with infinity, adding on a certain number, a set number, essentially is going to be ignorable. Okay, because eventually, even if you're adding on 50, infinity plus 50 might as well just be infinity. Because when you get up to the 50 trillions, adding on 50 is going to be negligible. So get used to just kind of ignoring those pluses or minuses, because with the weight of the size of these numbers, they don't do anything. So infinity -1 might as well be infinity. Over infinity is 1. If you weren't convinced about that, you could plug in like a 100. You'd get 99 over 100, which is 0.99. If you plugged in 1,000, you'd get 999 over 1,000, which would be 0.999, and so on. And obviously 0.99, then 0.999, then 0.99999 is always getting closer to 1. And then the same is true on the bottom, that the +1 can be ignored. It's just infinity over infinity, which is 1. Raise your hand if you got this one. If you think you got that one. Lexi, what'd you get?
I said it was 1.
It's also 1. That is correct. Okay? You might have guessed going into it that maybe it's -1. The truth is, those predictions that I ask you to like think about, what do you guess it might be, really have no basis. You really always want to plug it in and figure it out. So again, if we're going in the negative direction and taking the cosine of that number, it's still oscillating between positive 1 and negative 1. Just 1 second, Joseph. So negative infinity minus positive 1 is the absolute max that the cosine can be. Or negative infinity minus negative 1, because negative 1 is the absolute minimum that the cosine can be. And these leave you essentially with negative infinity over negative infinity, which the double negative makes it 1 as well. This is negative infinity plus 1. We ignore the plus 1. Negative infinity divided by negative infinity is 1. Joseph.
If you wanted to, could you factor like a negative when you plug in negative infinity? Would that just be like a waste of time? It'd be like,
Here.
yeah. No, and you first plug in negative, yeah, right there.
Factor out a negative 1, and so it would be infinity plus cosine of negative infinity.
Yeah, and then cancel the negative.
That's fine. Hannah?
Is the sine of infinity and the cosine of infinity both one, essentially?
No. There is no such, the sine of infinity itself does not exist. Because
So then what
this,
is that like 1? What is that like minus, like infinity minus?
so when you go towards infinity with cosine, you're constantly going back and forth between 1 and negative 1 and everything in between. So to say what is the cosine of infinity alone as a question doesn't make any sense. But what we do know about it is that, like I said, it's going between 1 and negative 1. So at max, this will only ever be 1, which is ignorable. And at minimum, the value of this portion of the function at minimum will only be negative 1, which, again, you're just adding on 1 or subtracting 1, or you're adding on 0.5 or subtracting 0.5. That number that you're adding on or subtracting on is completely ignorable when you're talking about infinity plus it. Okay, Tori?
It's kind of a really stupid question. I don't even want to say it out loud.
Okay, we'll move on. If you want to ask it, you can ask it after class. All right, on this next section, we have a rational graph and a linear graph, pretty much. Plug in negative infinity. So 5, or any constant for that matter, over infinity. Raise your hand if you can tell me that that will always be essentially, Mackenzie? 0. 1 over infinity, 5 over infinity. Again, that even if it's 100 over infinity, eventually when you get to those really humongous infinite numbers, 100 might as well be 1 because they're so non-significant. Constants really lose their significance altogether. So this, and granted it's approaching 0 from the negative number side of things, but it doesn't matter. It's still approaching 0. And this is plus, because of the double negative, infinity over 3. Now when you multiply infinities and divide infinities, there is something to be said for that. So that can cause things, but infinity, when you divide it by 3, is still infinity. It's just not going at quite the same rate as just a 0 plus infinity would be going, because you're cutting it in thirds. But by the end, it's still approaching infinity. So this is still infinity. Because I put it on my calculator and I forgot to show it to you, this is what the graph of that last function looked like, that cosine one. So you can see it as we go towards infinity, we're oscillating but towards 1, and as we go towards negative infinity, same thing. You also can see a vertical asymptote at 0, which should make sense because you have that x in your denominator. This 5 over x minus x over 3 graph, well, we can see as x approaches negative infinity, this is going towards infinity. It's not flattening out at any horizontal asymptote. So when your answer, as you approach infinity, is an infinity, you then know that there is no horizontal asymptote in that direction. Okay? On this next one, plug in negative infinity. The plus one, we might as well ignore. When we take negative infinity and square it, it just becomes infinity squared. Right? The negative gets squared and it becomes positive. But then when we take the square root of it, it's just infinity. The square root of infinity squared is just infinity. And negative infinity over infinity is 1. Give me 1 second, Tori. And give me 1 second, everybody. We have done functions like this, but I think we did them from a little bit of a different vantage point. We did them based on our degree rule, right? So this has a degree of 1. This technically will have a degree of 1. So the horizontal asymptotes would come from same over same, which would be 1 over 1, which is 1. But this is where we had 2 horizontal asymptotes, potentially. Positive 1 if we were going towards one direction, and negative 1 if we were going towards the other. Is that what you all are going to say?
Yeah.
Sorry. Negative infinity divided by infinity is negative 1. My bad. Joseph. Oh, sorry. You have to wait because Tori had her hand up first. Tori?
How come when you do the square root, like, that was an x still? Remember we had this argument earlier about how we all said it was like this x and then you don't know this absolute value of x, whatever it was? Yeah.
That.
Yeah.
Yeah. That is kind of the reason why you have 2 different asymptotes in a way.
Why can't it be infinity or negative?
Because this one, you're definitely squaring, because this is part of a polynomial, you're definitely squaring it first. You're definitely immediately going to turn it into a positive. And so when you take the square root of that, it's got to be a positive. Okay? Now, Joseph?
That's enough.
Oh, okay. Mackenzie?
So if it was just square root of x squared, would you have to put negative infinity if there wasn't the plus 1?
If it was the limit of x over the square root of x squared. That?
Yeah.
This you can't tell me that that's, well, for a limit, you can't tell me that that's x over x, no. Because what happens if x is a negative number, like negative 5 over the square root of negative 5 squared? If you tell me that this equals x over x, then that means you're telling me this equals negative 5 over negative 5, which it doesn't.
But I mean, for the infinity, would you have to have 2?
Yes. Because if you send us towards positive infinity, that's going to be a positive infinity over a positive infinity, and that would be 1. So there are still 2 horizontal asymptotes if you're on this one too. Was there somebody else, Hannah?
Yeah, when you like square that negative infinity, why is it still infinity squared? Would it just be positive infinity? Like, why is that second square root there still?
I was just kind of getting rid of the negative at first. Because like if you take negative 5 in parentheses and square it, that's still just 5 squared. And I was keeping it for the moment because I still had yet to do the square root of something squared. Okay? 3 will be pretty easy. I just want to talk about 4. We're not going to use our calculators right off the bat. I do want you to plug in infinity into f of x, and we will get the absolute value of 3 times infinity plus 2 over infinity minus 2. The plus 2 and the minus 2 are definitely negligible. They do nothing. But the multiplier of 3 does do something. Because the numerator has a multiplier of 3 on its infinity, it's always going to be 3 times the magnitude of the denominator. Yes? Give or take a minuscule amount because of the plus or minus 2. But for all intents and purposes, this is 3 times infinity over infinity, which is 3. Now, we did do these types of horizontal asymptotes with absolute values involved. We did use our power rule of same over same, so 3 over 1. But we also had 2 horizontal asymptotes in cases like this as well. One at the positive 3 and one at the negative 3. Because if you look at this, if you approach negative infinity, your numerator is still going to be 3 times infinity because the absolute value signs. And your denominator is going to be negative infinity, and that will be negative 3. I think that was the best class we had all year.
That was hard.
I love your challenge.